and that's the domain. Number 35, same thing. What I'd like to do first is factor that bottom. So when I factor the bottom, that's going to give me x times x, 3 times 1. The 3 is bigger, so it gets the positive. The 1 is smaller, so I get 3 minus 1 equals positive 2. That means x cannot equal negative 3 or positive 1. Those are going to be my asymptotes. Let me get the graph to start. And right now in a hurry, I know that I have a vertical asymptote at x equals negative 1, 2, 3, and at x equals 1. Let's see where my horizontal asymptote is. The degree of the top is 1, the degree of the bottom is 2, so that means I'm going to have a horizontal asymptote at y equals 0. I'm going to start to locate my intercept, so I'm going to plug 0 in for 6. When I plug 0 in for x, when I plug 0 in there, 0 in there, and 0 in there, this is 0 plus 1, and that's 0 plus 0 plus negative 3. That's going to give me negative 1/3. So I know there's a y-intercept at 0, negative 1/3. Then I set the top equal to 0 to find the y-intercept. So it's going to give me x plus 1 equals 0. X equals negative 1 is the y-intercept. So at negative 1, is the x-intercept. There's another intercept. Yes, there's allowed to be an intercept on the asymptote. So I have my two intercepts. Now I'm going to table it from negative 1, 2, 3, 4, from negative 4 to 2. To table it, I'm going to hit mode 7 and type in the equation just like it looks. Fraction bar, alpha x plus 1, and then alpha x squared plus 2 alpha x minus 3. And I'm going to start at negative 4, and I'm going to end at 2. I can just plug these in individually, but this is going to give me all the answers in a hurry. So those are all my values. I can see where they're positive, negative, undefined, and 0. So let's plot those points. Notice at negative 4, it says it's negative 0.6. So at negative 4, it's going to be a negative value. Once I have that negative value, I know my graph is going to go like this, contained between those asymptotes. At negative 3, it says error. At negative 2, it's positive 1/3. So at negative 1, 2, it's positive 1/3. I can see the slope of this graph is going to come down, go through there, and head downwards. Now at 2, it's probably going to be positive, but let's see. At 1, negative 1 at 0. At 0, it's negative 1/3. Error at 1, and 0.6 there. So knowing that it's positive in that zone, it's going to look like this for the rational function. On the domain, it goes up from negative infinity all the way to positive infinity, but there's a break at negative 3 and a break at 1. So that's going to look like this, parenthesis, negative infinity, almost to an 8, comma, negative 3, parenthesis, it doesn't touch 3, union, negative 3 to 1, it doesn't touch 3, there's an asymptote there, union, and it picks up at 1 again, it doesn't touch 1, to positive infinity, and that's the whole domain. 36, I can factor the top, so let's do it. So that's going to be x plus 3 times x minus 3. Nothing simplifies out, so there's no holes. There's a vertical asymptote at x equals 2. Y-axis, x-axis. Vertical asymptote at x equals 2. Degree of the top is bigger than degree of the bottom, so that's going to generate a slant asymptote or an oblique asymptote, so I have to do synthetic division. The bottom, the 2 goes in the backwards box, a 1, a 0, and a negative 9. This is going to give me my equation of my slant asymptote, so that's 2, and that's 2 there. And then I don't need the remainder of the last one, that's going to be x plus 2. Y equals x plus 2 is my oblique or slant asymptote. So I begin at 2, and I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and that's going to be my oblique or slant asymptote. Not my graph, my asymptote. Now we can generate a couple of points. I'll come up here and I'll throw in a 0 for the x and then see what the y produces. So when I throw a 0 in there and a 0 in there, that gives me negative 9 over negative 2 or positive 4.5. So 0, 1, 2, 3, 4.5 is a coordinate. Then I set the top equal to 0. Set the top equal to 0. When I do that, notice I get negative 3 and 3. So negative 1, 2, 3, there's a root or a 0. And at positive 1, 2, 3, there's a root or a 0. Just with that given information, I can graph this function. It's going to come along this asymptote, then curve up through this point, and then go up along that asymptote forever. This one's going to come along this vertical asymptote, go through that point, and then turn right along that other slant asymptote. And that's the general graph.
Number 37 is a little bit of a challenge. I can see that the bottom is going to factor pretty rapidly as x plus 3, x minus 3, but I don't know what the top is going to factor into. It has a leading coefficient, so that means it's going to be a little troublesome. So I'm going to take this and I'm going to try to factor it. So what I'm going to do is I'm going to rewrite it and try to factor 4x squared minus 13x plus 3. And there's a couple of different methods. I like to do the circle box method, I call it. It's called the Yiddish method. I take this negative 13 and I put it in the circle. And then I rainbow this 4 times 3, and that's 12. And now I find factors of 12. And the first factors, 1 times 12, are going to work. 1 times 12 equals 12. But in order to add up to negative 13, they both need to be negative. So those are my factors that I need. Then I'm going to come over here and I set up a little fraction bar and I put that 4x underneath of it, and I do it again because there's going to be 2 factors. And I just plop that negative 1 and negative 12 on top. Negative 1, negative 12. And this is going to be my first factor, 4x minus 1. I'm going to put that up in my factor up here. And then my second factor, I notice it can simplify. 12 divided by 4, negative 12 divided by 4 is actually negative 3 over x. So my other factor is going to be x minus 3. Now if we look closely, we'll notice that the x minus 3 and the x minus 3 will simplify. So that means there's going to be a hole over here at x equals 3. There's going to be an open hole somewhere along that graph, not an asymptote. The asymptote is going to be at negative 3. So I'm going to have a vertical asymptote at x equals negative 3. So I go left 1, 2, 3. That's going to be my vertical asymptote. And I also notice that the degree of the top is to the second power and the degree of the bottom is to the second power. So my horizontal asymptote is going to be this coefficient 4 over this hidden coefficient of 1. So y equals 4 is my horizontal asymptote. So I go up 1, 2, 3, 4, and I strike my horizontal asymptote. Now what I can do is find some zeros. So I'm going to look for where x is 0, and then I'll look for where y is 0. And the method for finding this, you just take the 0 and plug it in for every x value. And notice if I put a 0 in for x, I get a 0. If I put a 0 in for x, I get a 0. So that's going to give me 3. If I put a 0 in for x, that's going to give me negative 9. So negative 3/9 simplifies to negative 1/3. So that's going to give me a y-intercept of negative 1/3-ish. Notice I made a big dot there to cover myself. Here, let's see, negative 1/3. 0, negative 1/3 is a intercept. Now, to find the 0 for the x-axis, you basically just take the top. Take the top and set it equal to 0. So 4x minus 1, set that equal to 0. That's going to give me 1/4. So at 0.25, 0 is my other intercept. Now my graph, looking at the asymptotes, I can tell that my graph is going to come up along this vertical and then head over towards my intercepts. And then right around here somewhere, there's going to be a hole. I don't know that exact number yet, but I can plug it in to the simplified version to find out where that hole actually is. So if I have 4 times 3 minus 1 over 3 squared minus, over 3 squared over 3 plus 3, I have to put it in the simplified form. So when I put my 3 into the simplified version, that's 12 minus 3, 12 minus 1, that's 11 over 9, over 6. 11 over 6. And I'm going to find out what that is, what that decimal equivalent is. And it's about 1.8. So this graph is a little off. It's going to be at 1.8 is where my hole is going to be. So I'm just gonna make my graph a little bit more accurate with that hole. So it's gonna go through that hole, and that's gonna be that portion of the graph. The other portion of the graph is gonna be up in this zone and go up in in that area.
I've been using the Casio, but in this class you're technically supposed to be using this TI-84, so I'm going to go to y equals, and I'm going to plot those points. The first thing I want to do to get the fraction is hit alpha y equals. When I hit alpha y equals, notice it gives me an n over d option. When I hit that, it gives me a fraction. Now I can type in the equation just like it looks. For the x is up here, x, and then you find the square button, 4x squared minus 13x plus 3. There's certain aspects of this that are more convenient than the Casio, and certain ones that are not. X squared minus 9. Maybe I'll set the window. I know it's supposed to be from -3 to 3, so I'll mess around with my window. And notice my window is from -10 to 10, which is nice. I won't need the y values to go so low, so I'll make everything 10 by 10. And then when I graph it, it'll give me a picture of the graph, but it will not graph the asymptotes, I don't think. Notice it doesn't graph the asymptotes. And it gives me a nice picture of it. And we got that on the TI. Notice if I hit second trace and go to value, and I type in a number, it will give me the value of that number. It's pretty nice. And if I type in 3, there's a hole at 3, it gives me no answer over there. See how there's no answer at y? But if I type in 3.0001, it'll take me just to the right, 1.8. If I do 2.9999, it'll give me right to the left of that. But when I type in the 3, it doesn't give me any value. Number 38, composite functions. They want me to plug a 1 into g first for a. So when I plug 1 into g, that gives me 1 minus 1, which is 0. So then I'm expected to find f of 0. And when I find f of 0, that's going to equal the square root of 0, which equals 0. Not too difficult. Part B, they want me to put 1 into f first. So when I put 1 into f, that's going to be the square root of 1, which is 1. So then I'm expected to find g of 1. When I throw 1 into that, that's going to equal 1 squared minus 1, which is also 0. And then part C, f of g of x, they want me to do g into f, is what that means. So I'm going to take g, this value, and plug it in to that function. So I have the big square root, and what gets plugged into the square root is g, x squared minus 1. And that's it. Can't really evaluate it, you plug it in. 39, f minus g, so I'm going to take this, f, and I'm going to subtract this from it. So for part A, it's going to be x squared plus 3x minus 4 minus, and I have to wrap this, otherwise I won't distribute the negative. So it's going to be x squared plus 3x minus 4 minus 5x plus 2. So that's going to give me x squared minus 2x minus 2 for my part A. My part B is a fog, so that's going to be basically plugging g into f. And my f is x squared plus 3 times x minus 4, and my g is this value here. So I have to plug in 5x minus 2 and 5x minus 2. Some people just FOIL it out. I do a punt it, find out what 5x minus 2 is. Some people can do it in their head. They know they're going to get a 25x squared. They know they're going to get a 4. But then when I do this, that gives me negative 10x and a negative 10x. So I have to double it. So that's going to give me 25x squared minus 20x plus 4, distribute the 3, plus 15x, plus, minus 6, minus 4. Notice the 4 and the 4 will cancel out when I combine like terms. 25x squared, negative 20x plus 15x is minus 5x, minus 6. Part C, they want me to plug 2 into the g part. When I plug 2 into the g part, that's 10 minus 2, so that's 8. So I'm basically expected to find f of 8. That's going to equal 8 squared plus 3 times 8 minus 4. 64 plus 24 minus 4. 24 minus 4 is 20. 64 plus 20 is 84. Solve the systems of equations, no calculator, I'm not afraid. I'm just going to use elimination, so that's 3x. That's elimination equals 3, so x equals 1. Then I'm going to plug x equals 1 back into this equation. So it's going to give me 1 plus y equals 2, so y is going to equal 1. So the coordinate where they intersect is going to be 1, 1. Use elimination for this one as well. It's going to give me 7x. Eliminates equals 14. That's going to give me x equals 2. I take that 2, I plug it back into one of these, I'm going to plug it in there. 2 times 2 is 4 minus 3y. So here's my 13. Subtract 4 from both sides. That's going to give me negative 3y equals 9. When I solve that, I get y equals 3. Y equals negative 3. And there's my solution. X equals 2, y equals negative 3. So 2, negative 3 is the solution.